So welcome all of you. As I sent a mail, today's focus is going to be on method types. I'm sure most of you are, or many of you are aware of it. The class methods and static methods, and then I will talk about polymorphism. Then some special methods we'll see, few of them, not all the special methods available. So that's going to be the focus. So before I start, I hope I saw some 9 submissions so far on the lab 8 yesterday's assignment. So please submit it on the classwork. You don't need to send a mail. I have already created an entry. You can do that on classwork. Okay, classroom. Okay, so this is the reference. Now, when we have object instances, that is, a class is there, and then we create objects of that type, and then we call with respect to object any classes, methods. Then what happens is this object reference is passed as a default first argument. Object reference is passed as a first argument. As you know that in C++ also it happens. Only difference between what we see in C++ and in Python is this hidden parameter is really hidden from the user. Okay, most we will not even know. We don't write it, but it gets passed. So unless we dig deeper into it, or you know the language, you will not even know that this pointer, which refers to the object, is passed as a first parameter for all the object instance methods which are called with respect to objects. The first parameter is this pointer, which is getting passed default. And C++ language also freezes the name of this as this pointer, and we don't see that being really passed as a first parameter. We normally pass some parameter which looks like a first parameter in the method, but when it is invoked, it is the second parameter always. So if you are writing everything in C++ and you are interfacing with the functions methods, you don't even need to know, or you are supposed to know, but you don't bother. If suppose if I am writing a method, method 1, and then we pass parameter p1, then we can use it as a p1 here. We don't need to worry. Really, it will fetch the parameter properly. But if suppose you happen to write an assembly function, okay, assembly function if you are writing, in the sense the method whatever you are calling is written in assembly, okay, then the method is passed as a parameters, some 1, 2, 3, and this implementation is in assembly, suppose, okay, in some processor, maybe in ARM processor, or you are doing it in Intel processor. What happens is, I think I have mentioned it earlier, these parameters are meant to be passed in specific registers into the assembly function. Now, suppose if you are writing a ARM assembly, the parameters are supposed to be passed in registers R1 to R1, R0, R1, R2, and R3. And if you happen to pass more than 4 parameters, then the parameters which are beyond 4 parameters, they are passed in the stack. So when you come into the assembly function, the stack pointer will be pointing somewhere. In ARM, R13 is a stack pointer. Then what happens is the stack pointer, or R13, points at the 5th parameter which is coming in. Then what about the 6th parameter? Then that will be based on how the stack is growing. Suppose this is the lower address and this happens to be the higher address, and you are going towards the higher address. Then if it is growing like this, it would have been passed prior to that method invocation. So 6th parameter will be here, 7th parameter if it was there, it will be there, and then you are in the function where you are entering here. So if you want to access any of these parameters, the assembly function should know a priori that these are the parameters are coming in, how many parameters the assembly function is expecting, and then you need to write your assembly code such that you access them in a right place. Now you may wonder, we normally learn that the parameters are always passed to stack, but it is not the case, because passing through the stack is always expensive because you need to access it using the memory accesses, which is load and store instructions, which consumes more memory. So the processors, they have agreed upon a standard that few parameters, if the functions happen to have few parameters, they will be passed in the registers. That means the assembly routine, when it comes in, it knows that the registers R0 to R4, R3, R1, R2, R3 are already filled with the parameters. But only thing is, the assembly function should know whether it is expecting one parameter or 2, 3, 4, or maybe none. Based on that, it will look into those registers and process it inside. And then returning is also again decided based on registers, and which is happens to be the R0 register. So by now you know that the parameters which are coming in through registers are getting overwritten when you are returning from the method or a function, assembly function. That's why we normally don't expect these registers or the parameters value P1, P2, whatever you are passing, expect to have those values, because the calling function will modify them. Okay, and there are some these are all called application binary interface, ABI interface, which if you are interested, you can go into the processor details and learn about it. Why I'm bringing it here is, when you write a C++ method, you cannot expect the first parameter that you pass in the method to be available in R0. It will be in R1, because R0 is going to be pointing at this pointer, okay, which is the pointer to the object, which is whose method is with respect to whom the method is getting called. So R0 is default is getting this pointer, and the remaining registers are going to be having the first, second, third parameter as far as the C++ method is concerned. So I am talking about C++ and the assembly function, which may not be relevant to Python, but I thought it is good to know this, because I'm going to explain you something, how these default parameters which are getting passed as a first parameter are processed by the Python methods. Okay, so this will give you some idea that always do not assume, even in the interviews, if they ask you that are all the parameters passed always in the stack? No, there are few parameters. Normally in ARM it is 4 parameters. So normally the methods which are having only 4 parameters, they will be called by passing the parameters in the registers. They don't need to access the stack, then that will be executed fast. So in case if you are writing any methods, please be conscious that if you increase the number of parameters beyond 4, then you are going to incur some loss in terms of performance, because the parameters are going to be accessed from the stack. So even you can optimize it further. Suppose if you have to write a function which is having more than 4 parameters, you can order the parameters such a way that the parameters which are likely to be not used, or maybe based on some conditions you are going to use, those parameters can be passed later, and the parameters which are going to be used more often, they can be passed first. And then what will happen is, your method may not access the 5th parameter at all. In most of the cases, maybe based on some flags here, you are accessing some parameters, then you can order them so that your method will be more efficient. Okay, this kind of some optimization you can do. In case if you have an option to structure your code that only maximum 4 parameters you are using going to be passing to a method, then it will be more efficient. Now please remember, in a Python function, okay, Python function, anyway you don't need to bother about the first implicit parameter. You are going to be writing either class or self as a first parameter. So you are accounting for it already, the first parameter which is coming in. So you don't need to comprehend it separately. But in C++, the methods will be, you need to assume that if you pass only 3 parameters, it will be more efficient. If you are passing more than 3 parameters, it will be inefficient, because this pointer is coming as a first parameter in C++. So which is implicit parameter, which you won't see it when you are writing the code. So this is a difference between the way Python and the C++ behave. And then I think the Python designer, our friend Guido, thought that it is better to be specific, or instead of keeping it implicit, make it explicit that the first parameter is coming in, so that you are well aware that it is not hidden there. Okay, like C++. There's some difference between the way they handle this implicit parameter coming to the object. Now, just to be sure you are aware of why do we need this parameter. Okay, so class some C is there, and then you have some parameter, attributes, which are class attributes. Then they need not to maintain at the object level. But if you are having some self dot something, and then you are initializing it, then they need to be maintained at the object level. So what happens when you are instantiating an object of this class? The object memory is created, and assume that the self is a pointer which is pointing at that object. So you create object 1, then object 2 is created, that the self parameter will be pointing at the memory of object 2 memory. And then within that you may have this A and B instances, multiple instances of A and B within them. So when you are accessing it with reference to obj A, it gets accessed because of self parameter pointing at this object, whereas when you are accessing A of obj2, it gets accessed because self is now pointing at the new object which is in the memory. So all the object instance variable or instance attributes are maintained at the object level, and the memory pointing to the object is passed as a first parameter to the method instance methods which are accessing the instance attributes. Okay, so this is how internally they get managed. So what is self? Self is nothing but a pointer to the object where it is in the memory. Okay, fine. Now if you look at if you print it, suppose if you want to be really sure the self what is coming in for multiple instances are different, you can do id of the self inside the method. Then you will see that they will have different values if you are invoking it with reference to different objects. So I leave it to you. If you are very keen to do that, please do that. And when I am talking about class attribute, there is class level attributes. They come at a class level. Then you can see that different classes will have different addresses, whereas the same class will have the class attribute pointing to the same class object. So as I told you, class is also an object in Python. So it will have its memory. So class is the first parameter, which is a default parameter, which is getting passed to the instances which are class methods. I will talk about it. Now, if you are aware of already instance methods and class methods, then you will know that the first parameter happens to be CLS and then self. Okay, they are two different names, and CLS refers to the class object, self refers to the instance object. Okay, the address of where that object is residing in the memory. Okay, so please stop me in case if I am fast and not making any sense. You can always come online and talk to me. I hope this is clear. Anyway, it will become clear when I explain you the differences with the actual implementation. So the first parameter of an instance method is self. Now, one more thing, different documentation that you come across the internet, they say that self is a keyword. Okay, I don't know if you are also believing that self is a keyword. It is not. Okay, it is not like a keyword like a for or in or break. Self is not a keyword. You can actually inside the method, instance method, instead of self you can pass something else, and you can still access it, any of the self objects or instance of attributes, as long as you mention that first parameter as that. Okay, you can, instead of self you can write it as self, no issues. Okay, it will accept it. Okay, similarly class, which are meant for class methods, it is used as a CLS, which is a convention. I expect you all to use the same. Please don't try to confuse the person who is reading your code by writing something else. But if you are reading somebody else's code who is little bit uh, wants to confuse you, then you need to be aware that what is coming in for the instance methods, or first parameter is always a self. Okay, even if the name is changed, you should associate with that. Okay, I will tell you with the example so that you will understand exactly how to identify it. So what is a method, a class method? The first parameter of an instance method is a self method. A self, a Python passes the object to the method when it gets called with reference to an instance object, as I explained to you with obj1 and obj2. In contrast, a class method, okay, I put a plural here, affects the class as a whole and does not belong to any particular instance object. As you know that class attributes belong to a whole class, and any changes happening to the class attributes affect the whole class. By now you are aware of it. Any change we make to the class through a class method affects all of its objects. That means all the objects will see a change in the values of the class attributes. So within a class definition, you can associate, or if you want to say that a method is a class method, you can say add a decorator at class method, indicate that this method is a class method. Okay, that's it default. It assumes that the first parameter is a class object. The first parameter to the method is a class itself. The Python in tradition is to call the parameter as CLS because class is a reserved word and can't be used. You cannot use a class again as a parameter. A class method is a decorator to define a class method. Now we will see a method shortly in example code. Okay, now what is a static method? I will also, maybe before I come to a static method, we will see the class method and then come to the static method so that you understand. I have not explained the instant method because you are already aware of it. So let us now see a code. So as usual, we will take some code and then explain to save time. Oh, I have written already, so I could have used it. Okay, let me take everything and then explain you. Okay, now what I'm saying, we have a class with the class attributes in it. Now you know init is accessing self.obj, and they are, this is init is always no, you need to have a self parameter which is the object instance, because this is going to be called after the object is created by default, and it expects this to be getting a parameter which is a self. Okay, and you create those instance attributes using this self, means that it is going to be maintained at the object level. Now what is a class method? As I mentioned, you can create a decorator, put a decorator to mention that this is a class method. Now when you write it here, this is conventionally we are using CLS to indicate that this is the pointer to the class object. As I mentioned, class is an object itself, object in Python, and when you create this attribute, this is going to be accessing this, and we are initializing this attribute, okay, which is defined here. Okay, now what if I don't initialize it? Then this will be initialized by default. Otherwise I am passing a different value, then that will get initialized. Maybe I will write it as a default value. Okay, so now what is if I want similar to self, CL is not a keyword in Python, and the interpreter resolves it. Now, how does it know whether we are trying to access what we are getting? Okay, suppose I am writing a method. Okay, I am writing a normal method. I am not giving any decorator, but how does it know whether I am passing a first parameter as a class or a self? Now, it depends on what exactly you are trying to access. If suppose if you are accessing a class attribute which is defined here, then it will assume that the class is accessed. Otherwise, self, if it is a object attribute, if you are using which has been created by you in a methods in the init method, then it is assuming it as a self method. Okay, the object which is getting called. Now, actually, it is not based on this name, based on how you are invoking it. If you are invoking it with respect to the object, then what is coming in will be the object address. And if you are calling this method with respect to the class object, then it is going to be passing the class. So now I will give you an example and then explaining you that it is not based on this name, it is resolving it. It is based on how you are invoking it. Okay. So let us now look at the invocation part of it. Now let me include this definition also to just for my explanation purpose. I have put it here. Okay. Here I am trying to use both of them. Okay. Inside that. Okay. Let us print all methods, all attributes of both class attribute and method instance attribute. Now let us look one by one how I am invoking it. Okay. Now let us play around with this. Now you see I have created a my class, my object, and then I am calling print all attributes. Okay, this function with respect to object, print both attributes. I am calling it with a object. So that means they are getting called with respect to object instance, and this is supposed to be the object which is coming in, the pointer to the object. Now, if I try renaming it as CLS, okay, I'm confusing it for a while. Okay, I'll undo it. Okay, before that, let me first show this code which is working, and then we will do all the playing around. Okay. Okay, this is working fine. I am accessing the object attribute. Okay, it's fine. Now suppose I am saying that a class is not the, okay, now I did not use the class at all. So let me rename it as maybe ELF. Now, does it have any problem? It works. Okay, it works. That means what? This is, it's not a keyword in Python. You are free to use it, but as I mentioned, you should not do that. Now, what about this guy? I said CLS. So how do I know that I am getting a class attribute? So that is based on how you are invoking it. I need to call it with respect to the class name, which is nothing but my class. So let me take this function. I did not put it here, actually, I forgot. Now let me write my class dot. Now I need to invoke it. So what is happening here? I'm trying it for the first time. It expects a class name to be passed here, even with respect to the my class. Let me see whether I defined it as a my class properly. Now, okay, now I got what is happening is you need, I have not put this. Okay, I should use this method. I will explain you. Okay, wait a minute. Between this and this, there is a difference. Okay. Let me comment out this guy first for a while. Okay, there is one more parameter. So I need to pass that parameter, dummy param. Okay. Now let me explain it. Okay. Let us try to understand this here. Now I am calling it with respect to class. Now when I am invoking it with respect to the name of the class, then interpreter knows that I want this method to be invoked with respect to the class object. So I have one parameter anyway, but when I am defining it here, the CLS method, where is it? Okay, method 1, whatever, I defined it as 2 parameters here. Okay. Now, though this definition has 2 positional parameter, I am not passing it as a specific name here. I am calling it with respect to this, which is getting invoked like whatever we do normally in a object specific invocation also. We don't pass the first parameter. We call this with respect to object, right? Here we are calling it with respect to object, and then it gets passed as a first parameter when it is coming here. So similarly, when I am calling it with respect to the class, it gets passed here as a first parameter and it gets called here. Now I can rename it. Okay, I'm not calling this function. I'm calling only the class method 2. So I modified both. Okay, just to demonstrate that is no issues. Okay, I will go back to normal. Okay, so I don't need to have it like this, but default convention is this. Okay, now just to summarize, when you call a method which has been already given a decorator saying that it is a class method, then you don't need to pass the class method. Only thing is, you as an object, you need to call it with respect to the class method, class name. Then it gets called. Now what if I want to call this method? Print all class attribute, okay, which I am calling it with respect to, I am writing a CLS here. Here, what I should do is, I'll tell you the reason. Okay. Now, why I need this as well as this? By now, I think you might have made out what is the order in which the interpreter is resolving it. Now, it doesn't know where this function is. Okay. The scope. Sorry, anybody?
The screen is
Sorry.
working.
I am not able to. You are not audible. Can you increase your? Please talk loud.
Sir, your
Sir,
screen
your
is
screen is not visible.
Oh,
Yes,
is
sir.
it? Oh, okay. Sorry.
yes.
Yes.
Oh, I think I lost you. Maybe I got a sound, right? Something. So I was getting disconnected. I thought one of you is getting disconnected. I'm sorry. Okay. Is it visible?
Yes, sir.
Okay. Thank you. That's why I record it locally so that you guys don't miss out on whatever I spoke. Did you miss my talking also, or only screen went off?
Only screen.
Okay, fine. So now I think even if a screen is gone, you will be lost somewhere. So let me explain again, just to clarify all the doubts. Okay, in case if you have. Now, class method 2 is what? Is class method 2 what I have defined is a with a decorator. So it is already, I am informing the interpreter that this method is a class method. That means the first parameter what I pass, you need to assume that this is a, what you are getting is going to be the class object. Class object means is a different from instance object. The object of the class. Okay, so that is going to be your first parameter, and the second parameter is whatever you want, or if you don't want, whatever. Now this, when I'm invoking it, I'm still using this my class dot class method, because interpreter is in this scope, the main scope. It doesn't know where the class method 2 is defined, so you need to resolve it using the my class name. And then once I do that, it knows the class method is this, whatever this method, whatever I'm calling, it is defined as a class method from the decorator. So the first parameter is assumed to be the class object coming in. So I don't need to pass it specifically there. But if I have a method which I am planning to use it only to print class attributes, then also I will be, anyway, any method that I'm calling, I have to either resolve it with respect to the object name or the class name based on whether I am calling it as a class method or instance method. So I use the my class and then use the print all attributes. Now it expects me to pass another parameter which happens to be the class object. Now why? The reason is the print all class attributes, I have not given the decorator here. This decorator is not there. Then it assumes that the first parameter coming in is not the class. It can be anything. Okay, it's not like this class and this. Okay, I have written CLS here to make it clear to the reader or you and me, or developers, other developers, to know that I am expecting this to be a class object which is coming in, and I'm going to use it only to access the class attribute. So that's why this, it's not resolved automatically as class object name, and it is not getting passed. This object is not getting passed yet by default, and you need to specifically pass it. Okay, I hope this is clear to now. Now suppose, okay, what about the self? I think I'll change it again. Okay, I should not confuse you guys to write it like this, which is not fair. So everything is fine. Now what about the self object? Here, print all attributes. Now how do I call this print all attributes? Okay, init is default assumed to be called with respect to the object. Okay, we don't call it's a built-in magic function, whereas these are all other methods are all normal methods. So when I say print all attributes, here I am calling it with my object 1. Now this gets called with respect to the, now when I am calling it with respect to object, that gets passed, because we don't have any specific decorator like instance method in Python, right? Any method, if you don't mention anything else, it is default assumed to be instant method. So if I don't mention, it assumes that these are all instance method. Okay, and you need to be specific in your invoking it. I am actually using it only to pass a class object. So I am calling it with respect to class, and then I am passing the class object as a parameter. Now if I am calling this print all attributes, it default assumes that it's an instance method, and the first parameter happens to be the object name, object reference to the object. That's why I don't need to pass a specific parameter as a this itself here. Okay, if you do that, then you are calling this method with the 2 parameters. One is already being passed by the interpreter, and then one more you are passing it for whatever reason it is. So interpreter is not going to stop you from doing it, the compiler, but it will expect you to pass 2 parameters if you are again mentioning it here. Okay, maybe I'll do that. If I'm passing it again, it will say that I expect 2 parameters, because default it will pass 1 parameter, my object 1, and then it doesn't know what, for what reason, for what joy you are passing it twice. It will stop you from invoking it. Okay, so remember what is happening underneath and how different methods are being invoked by the interpreter. Now what if I want to access both the class object as well as class the means attributes as well as the object instance attributes? Then you need to specifically pass one of them. Okay, with respect, based on how you are invoking it, whether you are calling it as a class method or whatever, then you can pass it as a specific parameter and then invoke it. But don't expect that it will resolve it. If I put self comma class, then it will pass class object. No, it cannot. Okay, it cannot do that. You need to be careful about that. Okay, now anything else I want to explain here? So in summary, what I am trying to tell you is, instance objects or instance methods are default. They are assumed to be instance method if you don't mention it as a class method. Okay, and the first parameter will be default to be a self. Okay, if you want it to be a instance method, that's what I want to tell you that. Okay, now I hope this is clear. Let me see if I have anything else I want to explain you. Starting method. So before I come here, let us see the slides on what is starting method, and then we'll come back. So far you know there are only two things: instance method and then class methods. Okay, so these two you know, and then here self is a Python standard way of calling it with the first parameter. Class is the Python way of calling a default parameter to the class. Now, how do you invoke the instance method? You will be calling it with respect to object name. Then it is passed by default the object reference. And if you are calling a class method without the class method decorator, then you don't expect the class name to default call your class method. You need to pass it specifically. Otherwise, if you have this in your definition inside the class, then you don't need to pass it. It will be default assumed to be. Interpreter will take care of passing it. So it has the information about. So what is happening whenever it is invoking a method, it is going back to your class and then checking it whether this method is of what type, whether it is a static type or is it going to be instance type or is it a class method, what method it is. Then it is going to invoke it by either by passing a default parameter or expecting you to pass it specifically what you want to pass. Okay, so that is how the interpreter is going to process it. So what are the static methods? Static methods, much like class methods, are methods that are bound to a class rather than its objects. So you know that both class methods and static methods, okay, are bound to the class. That means what I am saying is their scope is also within the class and they are bound to the class and not the object. Okay, so it is not specific to object. So these methods, whatever you call it as a class method or a static method, they are all with respect to the class and they don't have any specific presence as far as the objects are concerned. So they don't behave or getting invoked with respect to any object. So you don't call these methods even if you have called a class method, okay, and then don't expect it to getting called by itself with respect to object. It will be with respect to the class, and this will be not with respect to the class or not with respect to the instance object. That means what? When you are calling a static method, suppose I am keeping it in the class C, a static method, then I will call it with a class name and then the method. Okay, I am calling it as a static method. Then I will be calling it with respect to this, but it will not pass the class object as a default here. Will it pass instance object? Anyway, you are not going to be passing as a calling it as an object name. You are calling it with a class name. So it is not going to default pass the class object reference. So it is just a method which happens to be residing within the class definition. That means you have kept this method within the class definition just because it is good to be here. Okay, you want it to be here, but it is not going to be anything specific to modifying any class attributes, and you are not going to be calling it with the decorator class method. You are going to call it with a decorator, which is a static method. You are going to have a special decorator to say that this method is a static method. That means interpreter, when it is getting invoked with respect to the class name, it is not going to pass a default class object reference as a first parameter. So it is going to call it just the method name without the class name, okay, class reference. So now why do you need a static method? Okay, I will come to that. They do not require a class instance creation. So both of them here I am saying class instance, actually it is object creation. Okay, don't confuse with the class object. Class object gets created when you define the class. Okay, when you define the class itself, it is getting created. Okay, but if you are calling it with this class name with something, then that will be used. Okay, if you are calling a class method, otherwise it exists. This class definition is there, that means it exists in the memory somewhere as a class object. It exists. Okay, and if you are defined some class attributes, they also will be existing in that memory. Okay, now if you are invoking a class method, then this object reference will be called, and then this method, whatever class method you are defining, they can access these attributes freely. Did I get lost? I hope you are able to see my screen. Okay, I'm still alive. Can you confirm? Okay. So let us come back. I took actually more time, so let us stop with this. The difference between static method and a class method is, now what is the difference? Static method knows nothing about the class. That means when I say nothing about the class, it doesn't have information about the class attributes and just deals with the parameters. Okay, it just receives some parameters. It is not expected to receive the class object as a first parameter or anything. Okay, there is no convention. Class method works with the class since its first parameter is always the class itself. Okay, that's a difference. Now both these methods can be called by a class or by its object. Okay, now okay, actually I should say only the static method. Okay, this name maybe I will remove it. Okay, this may be causing confusion. I will remove it. Okay, I will explain you with the example. Now static method can be created with a static method decorator. Static method is kept inside a class where it makes sense to have them part of a class, though it does not have to access any of the class or instance attributes of the class they belong to. Okay, so they neither receive the class methods, a class or a self as a default first parameter, so it cannot access both class and instance attributes. Okay, so unless you specifically pass some object attribute as another parameter, then it is free to use it, but it is not by default has access to the class attribute or instance attributes. So normally utility functions that don't need to access any properties of a class but make sense that they belong to a class, we can declare them as static functions inside a class definition. Okay, so I will not go there. Now I have 5 minutes. I will use this and then I will stop the class. Okay, so let me take out only this much. So static methods, we put a decorator. Now what does it mean? Now this is a first parameter which is getting invoked. It is not any default parameter which is getting passed by the interpreter. So if I am calling my class and parameter passed, this parameter passed is only coming as a param. It is, the interpreter is not going to default push the CLS here. Okay, the class object name here. Okay, that's what is the difference. So it gets passed and then I print a param, but when I say I am able to access it, okay, this method can access the attribute. What I meant by that is inside the method you can access the my class attribute by specifically giving it, because this guy happens to be inside the class. Okay, and then I am specifically calling it. You can imagine that this is going to be only one instance. Okay, the fact that this method itself is available and getting invoked, that means this definition has happened. This class object has already been defined in the memory, so I am free to use it even though I am not getting a parameter inside. Okay, as a CLS or something. So it exists. Whereas I can't say self something here, because unless I pass a object of this instance, I don't, this method doesn't even know some method is existing which belongs to this class or not. And default, it is not going to get any parameter which is a self parameter, which is a pointer to the instance object. So you need to be specific, pass up a object, and then you can call it as any object dot something. It need not be this instance of this object, it can be any object, okay, which you are free to use it. But static method has a freedom to access the attributes of the class because it is residing within it, and it can be invoked without giving the class object address to it. Okay, so now you may wonder how this is getting resolved, because when this method is getting resolved and the code is getting created, it knows that it is part of this class object, so it will know, the interpreter, the compiler will know how to invoke it. Okay, that's how it is going to, it's implemented. Okay, so I will stop here.